On the test, you're going to have to do a long division problem. Just like on the first test, you had to do a difference quotient problem. You're going to have to do one long division problem. But you may get to check it using synthetic division, right? We'll see. I don't know. Haven't made the test yet. That's coming. All right. So you've learned how to do synthetic division. Now we're going to talk about what is the remainder and the factor theorems. So the remainder theorem says if a polynomial is divided by x minus c, then the remainder is f of c. Note, the remainder theorem tells us that the value of f of c is the same as the remainder we get from dividing by x minus c. What does that mean? Looking up on the board, if you were to plug 3 into that original polynomial, guess what the value would be? 0. Okay, taking that and looking at it with this problem, here's your polynomial, and if you like seeing f of x here instead, given f of x equals x to the 4th plus x cubed minus 6x squared minus 5x minus 15, what is f of 5? Now, you could go push 5 store x, type that polynomial in on your calculator and hit enter, and it's going to spit a number out. And that's what I'm trying to show you down here. You can plug 5 into your polynomial, 5 to the 4th plus 5 cubed, on and on. Or you can go do synthetic division real quick. Meaning, what number is going to go here? 5. What number is going to go, what coefficients are going to go across? 1, 1, negative 6, negative 5, negative 15. Go play the game. Drop it down. 1 times 5, 6 times 5, 24 times 5 is 120. So you get 115 times 5. So what is f of 5? 560. Did somebody check me and make sure if you plugged 5 in, you would get 560? Do you? Mm-hmm. All right. Same polynomial. What is f of negative 3? So I'm going to go do negative 3, 1, 1, negative 6, negative 5, negative 15. Drop it down. 1 times negative 3, negative 2 times negative 3, 0 times negative 3, negative 5 times negative 3. What is f of negative 3? It's 0. So could you use the remainder theorem to evaluate a polynomial at a given value? Sure. Just use synthetic division, and your answer would be the remainder. Okay. Use the remainder theorem to determine if the given number c is a 0 of the function. So what does it mean to be a 0? C is a 0 if f of c equals 0. We also call c a root, and we say that C0 is an x-intercept, remember? That was all from last time. Those things are all saying the same thing. So how can you tell if c is a 0 of the function? You plug it in and see if you get 0. Well, we have a quick way to do that. Well, the quickest way is just to punch it in on the calculator. But let's go do synthetic division. Put 2 in. What are your coefficients? It starts with an x to the 4th. So 2x to the 4th. What do you need? a 0 for a placeholder for x cubed, negative 3 for x squared, 5 for x, and negative 11. Drop it, 2. 2 times 2 is 4. 4 times 2 is 8. 5 times 2 is 10. 15 times 2 is 30. Your remainder is 19. So what is f of 2? If f of 2 is equal to 19, is 2 a 0? No. Questions? Do I give you another one? Yep. Ew, and it's a radical. Is square root 7 a 0? So go put square root 7. Your coefficients are going to be 2, 5, negative 14, negative 35. Quick review on radicals. Drop it down. You get 2. 2 times root 7 is 2 root 7. Okay, 5 plus 2 root 7, right? Can you do anything to that? That's it. But now you need to multiply 5 plus 2 root 7 by root 7. So go distribute. You get 5 root 7 plus 2 times, what's root 7 times root 7?
7.
Just 7. So your answer is going to be 14 plus 5 root 7. Okay, what is negative 14 plus 14 plus 5 root 7? It's just 5 root 7. Now you need to go do 5 root 7 times root 7. What is that?
35.
It's 5 times 7. Oops, I put root 5. It's 5 times 7, which is 35. Your remainder is 0. Again, that says that f of root 7 is 0. So root 7 is a 0 of that polynomial. And now for yet another fun review topic, complex numbers. Is 3 plus I a 0 of that polynomial? Go set it up. You want to put 3 plus I here. What are your coefficients? 1, negative 7, 16, and negative 10. Bringing it down, you get 1. What is 1 times 3 plus I? Just 3 plus I. Okay, when you're adding complex numbers, you add the real part, and then you add the imaginary part. Do you remember that this is actually negative 7 plus 0i? We just don't write the 0i there. So what is negative 7 plus 3i? It's going to be negative 4 plus I. Now you need to do negative 4 plus I times 3 plus I. You've got to go FOIL it. First, outer, inner, last. If you don't like doing it that way, you open your calculator and you say, what was it? Negative 4 plus I times 3 plus I? Negative 4 plus I, which is above the decimal point. Negative 4 plus I times 3 plus I. Enter. What do you get? Negative 13 plus I. Negative 13 plus I. Had you done it by hand, you would have had negative 12 minus 4I plus 3I and then plus I squared. And what is I squared equal to? Negative 1, so you'd have had negative 12 minus 4I plus 3I minus 1. Collecting like terms, you get negative 13. Negative 4I plus 3I is, oh, sorry, that should have been plus, right?
No, it should be a negative I. I got negative I. Negative 13 minus I.
Yes, negative 13 minus I. Whew. One thing's wrong, but it's not. Say negative 13 minus I? Yes. Yep. Can I show you on the calculator again? Go to your calculator. You're going to type in exactly this times that. Okay? How do you get the I to come up? You're going to hit the second button, and the I is right above your decimal point. Give me just a second. We're right here. So 16 plus negative 13 minus I gives you 3 minus I. Back to the calculator. 3 minus I times 3 plus I, right? So 3 minus I times 3 plus I is 10. Negative 10 plus 10 is 0. So I know that f of 3 plus I is equal to 0. So 3 plus I is a 0 of the polynomial. Questions? I know you probably don't like working with radicals, you don't like working with complex numbers, but those are tools that you should have. Those are skills that you should already possess. And if you're lacking them, use your calculator. Okay, the factor theorem. Let f be a polynomial. Okay, remember back up here in red? Factor theorem is saying all this again. Let f be a polynomial. If f of c equals 0, then you know that x minus c is a factor. So all the things that you know. If f of c equals 0, then c is a 0, or we can call it a root. And we know that x minus c is a factor. And we know that c comma 0 is an x-intercept. All those things say the same thing. So use the factor theorem to determine if the given polynomials are factors of that polynomial. Is x minus c a factor? So what number is going to go in the half box? A 6. What are the coefficients across that first line? 2, negative 13, 10, negative 25, and 6. Drop it. 2 times 6 is 12. Negative 1 times 6 is 6. Negative 6. 4 times 6 is 24. Negative 1 times 6 is negative 6. Is x minus 6 a factor? Yes. X minus 6 is a factor. And you can even write because f of 6 is 0. We have another one. Is x plus 3 a factor? So this time what's going to go in the half box? Negative 3. Coefficients are the same, correct? 2, negative 13, 10, negative 25, and 6. Drop down the 2. 2 times negative 3 is negative 6. Negative 19 times negative 3 is 57. 67 times negative 3 is negative 201. Negative 226 times negative 3 is 678. My remainder is 684. Is x plus 3 a factor of that polynomial? No.